Hello students. So in this video, we're going to start with a new chapter that is the continuation of trigonometry actually. That is the applications of trigonometry. Some applications of trigonometry. As you know, in the very first video itself, we have discussed that the main application of trigonometry is used in finding the heights and distance. Let's say height of a mountain or a height of a big building or distance between two buildings. All this can be done with the help of trigonometry. Now in this video, we are going to learn how to find the heights and distance with the help of trigonometry. To do well in this chapter, okay, you have to be very thorough with the standard angles. Okay, that is a very important task. Okay, you must be very good at standard angles. Please practice the standard angles. Please watch the video also, which I've done on standard angles, and I've given you a small trick to remember the standard angles table. You can watch the video. Now let's start with the problems. Before starting with the problems, there is a small concept. Let's understand what is that. There is something called as line of sight. Okay, what is this line of sight? It is simply an imaginary line drawn. Okay, let's say we have a person. Okay, it's an imaginary line drawn from the eyes of a person to the object that he is viewing. Okay, let's say he's watching some car. This person is watching some car, or let's say anything. Let's take a ball. Okay, let's take a ball. Okay, now what is the line of sight? The line of sight is simply an imaginary line drawn from where? From the eyes of the person to the object that he is viewing. Okay, so this line, okay, will be the line of sight. Okay, and if this line of sight is parallel to the ground, okay, if this line of sight is parallel to the ground, then we call it as horizontal line of sight. That is, if a person is watching something, okay, if a person is watching something without lifting his neck or bending his neck, then that line of sight is known as horizontal line of sight. Okay, now here the person is neither lifting his neck nor he is bending the neck. So therefore, the line of sight formed is horizontal line of sight. Okay, now let's say there is a kite. Okay, this, let's say this is the ground. Okay, let's say this is the ground. Okay, and let's say there's a person standing. Okay, and let's say he is watching a kite that is flying above his head. Okay, now as you know, without bending his neck, he would be watching something, let's say a ball. Okay, like this will be the horizontal line of sight, isn't it? HLS, horizontal line of sight. Now if he is watching the kite, he has to lift his neck and watch it, isn't it? Without lifting his neck, he cannot watch something which is above him, isn't it? Therefore, if you observe, with the horizontal line of sight and this new line of sight, there is an angle formed. Okay, this angle we call it as angle of elevation. We call this as angle of elevation. Okay, when is this formed? The angle of elevation is formed whenever a person is viewing something above him. Okay, so then the angle of elevation is formed. This angle is between what and what? It is between the horizontal line of sight and the new line of sight formed by watching a new object which is above him. Okay, so this angle is known as horizontal line of sight. Okay, let's say line 1 is the horizontal line of sight that is obtained by drawing from the eye of the person to the ball. Okay, now let's say line 2 is the line obtained by drawing from the eye of the person to the kite. Okay, the angle between them, that is known as the angle of elevation. And remember, here the one will be parallel to the ground. Okay, because he is not bending his neck or he is not lifting his neck. Therefore, that line of sight is known as horizontal line of sight. Suppose that person, let's say now that person is on the ground itself again. okay, is watching something, okay, let's say something, okay, any object, okay. Earlier is horizontal line of sight was like this, isn't it? This was this horizontal line of sight. Now the person is watching something below. If he has to watch something below, or let's say there is an underground, there is something, okay, down here, okay, here, and let's say he's watching it. Obviously, if he has to watch it, he has to bend his neck, okay. Now the angle formed is called as angle of depression. The angle formed is known as angle of depression. See, we get angle of depression whenever person is watching below, okay, is watching something below, okay. Whenever is watching something above his head, then we call it as angle of elevation. Or the best example for angle of depression is, let's say a person is on the building, let's say is on a building, okay, let's say this is the building and the person is on the building and he is observing the ball itself, okay. Now without lifting his neck or bending his neck, his horizontal line of sight will be like this, isn't it? And now he is watching the ball, okay. Let's say the ball is here. Now, what is the angle of depression? This angle is the angle of depression, okay. Sometimes students take this angle as the angle of depression. That is wrong. See, angle of depression or angle of elevation, it is the angle between the horizontal line of sight. That is the line that is obtained by not bending or lifting the neck of the person, okay. This is the horizontal line of sight. Now he is watching something which is below, okay. Here is the new line of sight. This angle is called as the angle of depression, okay. Angle of depression, okay. So here we must be able to identify the angle of elevation and angle of depression. That is the very important task, okay. The next thing is, after we get to know the angle of elevation and angle of depression, one important thing is, see in the questions, what we usually we get a right angle triangle, okay. From the given data we'll be getting a right angle triangle for sure, okay. And trigonometrically basically uses right angle triangle, isn't it? From all the given questions we'll be getting a right angle triangle, okay. And let's say this is the angle under consideration. Now if this is the opposite side, I mean this will be the opposite side, opposite to 90 degree will be hypotenuse, and let's say BC is the adjacent, okay. Now the question will be like this. Sometimes they give you the opposite side, they'll give you the measurement of the opposite side, and they'll ask you to find the measurement of hypotenuse, okay. If that is the case, remember which ratio connects opposite and hypotenuse. It is actually sine theta, isn't it? Or cosecant theta. So sine theta is opposite by hypotenuse, isn't it? Or you can also take cosecant theta, because cosecant theta also connects hypotenuse and opposite, okay. But most probably we'll be taking sine theta. Why sine theta? Because they have given us opposite side and we need hypotenuse, okay. So we know this, we also know this from the question. We have to find this, therefore we are going to use sine theta. So if opposite is known, hypotenuse is not known, or vice versa. If hypotenuse is known, opposite is not known, then we are going to use sine theta. Suppose if you know adjacent side, if you know the value of adjacent side but you don't know the value of hypotenuse, in that case we are going to make use of cos theta. Because what is cos theta defined as? Cos theta is defined as adjacent by hypotenuse, isn't it? So if you know adjacent and you don't know hypotenuse, then you have to use cos theta. The vice versa also. If you know the hypotenuse value but you don't know the value of adjacent value, then also you can use cos theta, okay. Sine theta and cos theta, we use it very rarely in the problems. The most used is tan theta, okay. In most of the problems they'll give you the value of opposite side and you must find the adjacent side, or the vice versa. They'll give you the value of adjacent side, you have to find the value of opposite side. So opposite and adjacent is connected by what? Tan theta, isn't it? Tan theta is equal to opposite by adjacent. Or you can also use cot theta. Cot theta is what? Adjacent by opposite. Anyhow, adjacent and opposite are connected even in tan theta, even in cot theta, okay. Therefore, but most probably I'll be using tan theta. You can also use cot theta, no issues, but we will be using tan theta, okay, in the video. So remember, this is the most used, okay, in the applications of trigonometry, because in most of the questions, the opposite side value will be given. The adjacent side value, we have to find it. Okay. Or the vice versa. Adjacent side value will be given. Opposite side value should be found. In that case, we're going to make use of tan theta. Sin theta and cos theta, we use it very rarely. Okay. So in this video, we have learned what is line of sight. Line of sight is simply the line, imaginary line, okay, drawn from the eye of the person to the object that he is watching. And what is this line of sight? If it is parallel to the ground, we call it as horizontal line of sight. And if a person is watching above something, then the angle of elevation is formed. If he is watching something below, then the angle of depression is formed. Okay, students, in the next video, we'll be starting with the exercise problems. Thank you, students.